Hello, so welcome back to Daily Dose of Rust Language. Well, this is the part 2 of a series where we explore the power of macro in Rust. Now, in the previous video, we explained in detail what Rust macro is, how they compare to functions, the features it comes with, how it helps your code, how it helps you write better code in Rust. Then we gave 2 detailed examples to explain that. Now, we also talked about how there are 2 types of macros in Rust, the declarative macro and then the procedural macro. Now, a very big part of macros in Rust is the pattern matching, where you create a pattern to match a code, and once that pattern is matched, another code is written, usually a bigger code. Now, if you've not watched that video, check out that video, as that is very important for you to follow up this video really well. Now, in this video, we are going to go deeper, as I promised, to give you a few examples. So let's get started. Now, as an example, let's take a look at this function. Now, here we have a function called add. It takes 2 integers and then it adds them and return the result. Now, we are just adding numbers. If you need another function for subtraction, you can come in here and then do it, but it will require, let's just call it div, okay, and then we'll return the difference between these 2 values. However, this will require creating 2 functions, and in fact, if you want another function for division, you have to create another function. Now, let's use the power of macros to simplify this process for us. Now, what we are going to do is to create a macro that we can simply, by writing a simple code, is going to generate this function for us. Remember, in declarative macro, it will accept some code, match it through a pattern, and then generate another code from it. And that is exactly what we are going to do here. So to get started, all we have to do is to start creating our macro. Now, in the previous video, I went through the whole syntax. Watching that video is going to help you a lot in understanding the syntaxes here, but I will try as much as possible to explain them as well. So we make this macro exportable by using the macro export. Then we use the macro rules keyword, and let's just call it special function, okay, because it's going to allow us to create as many functions dynamically. Now, as you know, we need a pattern and then the code. So what we want to be able to do is this. Let's see what we can do and then know how to use it. We want to be able to call special function and then pass a name of a function. For example, we can pass add, right? And then we separate it with a comma, and then we want to pass the number of variables that we want to add. Okay, let's just use add as an example, and then we pass the type of values that will be inside this arrays. So let's say we want to add 1, 2, 3. We can simply do it this way. Now, by doing this, Rust will generate a function for us called add that will accept 4 parameters, which will be inside this array. All the items inside the array will be of type iterate2. Okay. Now, this will also allow us to generate another one for div. So by simply doing this, we will generate a new function like this instead of creating a function for every single case. Okay. And once we've defined it, we can simply come in and call this add function and pass some values in it, right? So let's see how we can do it. Let's just remove this one for now. Now, sometimes I like to create the code first before I start writing the pattern. Okay, you can do it however you want. So what we want to do is to be able to create a function, right? So we start with the fn keyword. So whatever is inside here is what Rust is going to expand the code to. It will take this and then it will expand it to whatever we wrote in here. And the name of this function, we want to call it something like name. Okay, that is what will come in here, right? And then next we open our parentheses. It's a standard way of defining a function. And we want to accept an array, right? So what we can do here is to accept the array. Since we want the user to pass an array, we can call these values, and the type will be dynamic, which is what is going to pass in here. So we're going to accept that in the pattern as well. So let's just call it type. Let's just call it T, okay, to make it simple. But since it's going to be an array, we are going to make it type of an array, and the type will be T, okay, and then the number of values inside it. So here is going to be 4. Let's just add another one. So it's going to be 4. So we store that inside another variable. Let's just call it n, okay, and then we want to return some value. Since if you are adding some value, the values we're going to pass inside the array is going to be of the same type. We can still use this type again that we call T. We can just return it here, okay, and then inside here we want to add all the values inside the array and then return the total. In fact, since we will not need to take ownership of this array, we can just accept it as a reference, okay. That also means we have to pass it as a reference here. In fact, since we are calling the function directly, we can remove this, okay, and put it in the implementation. Let's say we are inside another function and want to use this macro, the function we've generated from the macro. Let's just call the function foo, and then inside here we'll call this add that will now exist, and then we'll pass this value. Maybe we'll store it inside another value called a, and then we'll add the value, or let's just call it sum, okay. You can then print that to the terminal. Sum is equal to something, and then we pass the sum, okay. So this is what we want to do. We generate the function by calling this macro, and then we call it this way. So when we are calling it, we want to be able to pass an array of values it's going to add. So okay, so don't mind these errors that is showing now. We're going to fix it. Now here we are still generating the function. It will return the type T, which you are going to pass when we are generating this function. And then inside here, since we are accepting an array, we need to loop through the array and then add or perform some operation on all the values. So what we can do here is to create a variable that we call result. Now pay attention that these macro variables are quite different from these variables, okay. These ones are macro variables, you can't use it outside, okay, but these ones are normal variables in Rust. So the macro variables, you start each of them with a $sign. Now since we have this result, we can initialize it to 0, but since we want this to be dynamic enough such that we can also pass float right here, initializing it this way is not going to make much sense. So in order to make it simple enough, we need to pass the default value as well so that we can store it here. So let's call that default value default. We can then set it here, default, and then we end it with a semicolon. Now remember that we are still defining all this in the pattern and store them here and store them in these variables in order to use it here. You're going to see that in a second. Now the next thing we have to do is to loop through these values inside this array and then store the value inside the result. All we have to do is to use the for expression. Let's just store it in I, okay, and then we loop through this range. Since we will also get the number of values that will be inside the array, right? So since here is going to be 4, you can also store that somewhere else, like we've already used here, and then call it n. So between 0 and this range, and then we start looping through. And for each I value we got, we will add it inside result this way, okay. But this is not exactly what we want. Since we want it to be dynamic, it's possible that we are going to pass, it's possible that we might want to use it for subtraction too. So what we can do again is to pass the sign itself. So if we want to use it to generate a function that will subtract values, we pass the operator directly, okay. So we can do that here as well. Let's say after this, the name of the function, we pass the operator. Let's say for example in this case we pass plus. Okay, so we generate a function called add, and all the values inside the array will be added using this operator. If we want it to be subtraction, we pass minus here, and then the values inside the array is going to be 4 values. All of them will be of type i32, and the default value will be 0. So this is what we are aiming to do. So in here, instead of using plus thereby making it static, we can make it dynamic. Okay, let's just call it operator op or something like that. Okay, so we add it. If it was plus, this will be plus equal to this. Now that we've done that, at the end of the day, we'll return the result. Okay, so this here, we will generate a new function that we'll call name. Okay, and that will be add in this case. And the function will have a parameter called values, okay, which is going to be an array of type t. Okay, and then the number of values inside the array will be n, and then we will return type t, right? And then inside here, we created a temporary variable result here, and then we assign it to the default value which we are going to pass here. And why I added this default value is so that if we are working with float, we can easily pass a float, okay, because we can add both integers and float. If I decided to assign 0 here, then when we are adding floats, it will become a problem. So passing it directly when you are generating the function is the best thing we should do. Okay, now we look through the values and then add the values inside the result. In fact, what we are supposed to do here is to read the values from the item from the values I right here this way. So now we are reading the value from the array instead of just adding what we are looping through. Okay, and then we'll return the value. So this is the function that will be generated. Now let's work on the pattern. So since we want to accept this, now in Rust macro there is something called designator. Okay, we touched on it yesterday. For example, here it defines the type of value we are accepting. Here we are accepting an identifier. Remember, in Rust, an identifier is a name that you can give to a variable or a function. Usually they will start with an alphabet, so you can't start it with 4 or so. Okay, it has to start with an alphabet. It can also contain underscores and maybe numbers after the first value. Okay, so designators are ways that Rust allows us to mark this the values you are going to pass here. In fact, there are 11 designators in Rust. You can see in the Rust documentation where they explained designators. We have 11 of them here. We have block, which is just a block of code. We have this expression. We used it yesterday in our example, the 2 examples we gave yesterday about how to use macro. Okay, expression is a value that is like calculated, like when you do 1 plus 2. Okay, it's an expression. 1 alone is also an expression, even though it's also a literal. So if it returns a value, then it's an expression. Now, identifier is like names used for variables or functions. Like I was explaining before, any name you can give to a variable or a function is usually termed an identifier. Now, an item is anything that you can define in the module scope or in the crate scope. Like a struct, you can define a struct directly inside the module or inside the crate. You can define a constant, for example. You can define an enum, but you can't define a variable. A variable must go inside a function or inside the method. Okay, so anything you can define in the crate scope or in the module scope is termed an identifier. Okay, it's termed an item. We also have literals, which are just literal constants, right? Like if you have 1, or if you have a character, or if you have a simple string slice, they're usually termed literals. Okay, they're not calculated. They are at compile time. You already know what they are. Now you have patterns, which we've already looked at. Any type of pattern you have. You have path. We took a look at path in a previous video. Okay, where we talked about relative path and absolute path. That was when we in the series when we talked about when we explored code organization in Rust. You can check that out as well. You can see it in the cards. Then you have a statement. A statement is like the opposite of an expression. It doesn't return any value. Like when you have a code that ends with a semicolon, it's usually a statement. It doesn't return any value by itself. Then you have a token tree. We're going to see more about token tree when we start treating procedural macros in the next video. So make sure you are subscribed and like the video. We're going to explore, you see how procedural macros work, because they are not quite like the declarative macro. Okay, so for example, instead of in declarative macro you take some pattern and then you expand it to a bigger code or another code, but for procedural macros they don't work with patterns. So instead of generating a code from a code, what they do is they take your code and then they modify it. Okay, for example, we used some of them previously in a video when we use the derive macro, but we're going to take a look at them in the next video with examples, of course. So make sure you are subscribed and like the video. Then you have types. Types are like I32, F64, all those types. So we're going to use this in these examples we are exploring right now. And then you have VIS, which is visibility qualifiers, which is like public. And you know, in Rust everything is private by default, but you can make things public, but you don't have protected visual qualifiers like you have in other languages. So it's mostly private and by default, and then public. So now that we've seen these 11 designators that Rust has, okay, and what they are, let's see how we can use them in here. So add must be an identifier, which means it must be a valid function or variable name. Okay, so it's going to be the first value. So let's just call it name because that is what we called it here. It's going to be the name of our function, and then we use a colon to specify what it's going to be. So it's going to be an identifier. Okay, so we've taken care of that. After that, we are going to have a comma. Remember, we are not building the pattern. Now after that, we are expecting the sign, which for add will be plus, for subtraction will be minus, and so on. So whoever is generating a function by using this macro will have to provide the sign, and that will make it very dynamic. Okay, and signs are called token types. Okay, so they're usually represented with double T. So we can come in here and then say the operator itself. Let's just call it operator, because that is what we called it here. The operator is going to be of type TT, which is a token type. Sorry, which is a token tree. You can see here it's called token tree. For example, an operator, which could be plus or minus, can be a token tree. Okay, so in fact, see token as the smallest unit of a Rust code. Okay, usually when you compile a code, Rust will first of all tokenize all your code by breaking them down into bits and pieces in order for you to understand how to compile it. So for example, 4 is a very tiny part of the code. Okay, you can't break it down anymore, which means it's a token. Okay, that is part of what we are doing here. Plus, in this case, it will be a token tree, right? So now it's going to be followed by a comma. After that, we have a value which will represent the number of values that will be inside the array that will be passed here, right? So what we can do is to call it, we've already called it n, so let's just call it n here. Store it inside this meta variable, and then the type will be, you can say it will be a literal. Okay, just so we use some of it because it's actually a literal. It can also be an expression because it returns a value, which will be 4 in this case. And then after that is to be followed by a comma. And now we have this. This is actually a type in Rust. I32, F64, whatever you have represents a type. Okay, and we've called it T, which is what this function will return. And we even used it here, which will be what each item in this array will be. So we just call it T, and then we say it's going to be of a type ty. Okay, so this is the designator used for types, and then after that we're going to have a comma, and then lastly we have the default value, which in this case is going to be 0 since we are working with I32 values. Okay, we called it default here because that is what we initialized result with. let's just call it default, and we already know it's going to be an expression. Okay, can even be a literal, however you see it. So let's just say it's going to be an expression. Okay, you can see that Rust is warning us. It says the name add is defined multiple times. We have to remove this function here, because Rust is now already recognized that this will generate a function called add, and it's warning us to remove one. So you can just remove this one we have up here, and that will be good. Now pay attention to this, because I ran into this issue. Okay, if you know why we're having this issue, please let me know in the comment section, because for some reason Rust is saying expected expression found equal to. Okay, however, this should amount, or this should expand to something like this, plus equal to. Okay, when we run this code, since you are passing this plus sign, but for some reason it's not recognizing it. I also posted a question on Stack Overflow about this. So how I went around this is to, instead of doing this, I will set it equal to result plus the value this way. Okay, by the way, we will need to remove this, because this will be an actual value, which will be I at this point. We have to make this mutable in order to be able to modify it. And this is great. So all of a sudden, we now have a function called add by just simply writing this small code that we can use here. Okay, let's find a way to run this code and see what will happen. Then let's run the code and see what it's going to look like. Now we have the sum is equal to 10. So this is where it gets very interesting. Of course, if you take a look at it, 3 plus 3 is 6, plus 4 is 10, so it's correct. Now we can also do the same thing for subtraction. Let's just call it diff, and the sign will be negative. Let's say the value will also be 4, right? And it will all be this type. Let's say we do the same thing here, diff. We want to find the difference between all these values. So we can now say diff as well will be equal to this. And then we pass it here. And let's run the code to see what it will look like. Now we see the difference is also 10. Oh, but here we made a mistake here. We have to use the operator. Okay. And then we run the code again. Oh, sorry. Of course, we have to use the diff function we just created. And that was why Rust grayed it out here. So let's run the code again. Now we got -10. Okay. So it all makes sense. So this way we are able to define these ones and then be able to generate code on the fly. You can even do that for multiplication. Let's just call it mult, and the sign will be this. So coming in here, we can multiply different values. Let's say product, and let's multiply, let's say 4 and 2. Okay, I remember we have to define how many values we have to pass in here. Let's just say 2 values. Then we'll call multiplication. Okay, and you can see that the type system is also warning us here. You can see that the type system is also very intelligent, because it detects that when we generated this function, that we want the value to be 4. Okay, here the items in the array must be 4, but we are passing 2 here for diff, and it was able to detect that. So it's going to keep our code safe. Now we have the product. Let's see what that will look like as well. We say product is equal to this, and then product, and then let's run the code again. We got the product is equal to 0. So what is going on? Let's just print this to the terminal here. see what is going on. Because I will be equal to this, then result will be equal to this. And let's say the value will be equal to this too. Then here I, and then result, and then the value should be value I. There should be values. Then up here, let's just disable this first too, and also this. So we'll be calling the multiply function. Okay, so this ran a couple of times. The first time I was 0 and the result was 0, while the value was 4. The second time I was 0, I was 1, and the result was still 0 and the value was 2. So something is wrong. After multiplying results and the value, we are supposed to get a valid result, but we got 0. Okay, and that is because 0 multiplied by the value will be equal to 0. See, and that is quite interesting, and that is because the default value we are passing is 0. So on the first time, if you multiply 0 and 4, you still get 0. So the second time, you will also get 0. So we need a different strategy here. This is why it's good to test your code. I mean, we can set the default to 1, but of course, it's not really a good idea. Another thing we can do, instead of passing this default value, okay, we can always use the first value inside the array as the default one. Let's see what that will look like. So for example, we can come in here and then say values index 0. But again, what if there is no value in the first item? And of course, if you do this, since we are counting from the index 0, it means the first index will already be here. And if we multiply it, let's say the first index was 2, and if we multiply this value for the first item in the array, we'll be doing that 2 times. Okay, we'll be doing like 2 multiplied by 2 again. So we need a different approach. Maybe what we can do here is this: if the array is empty, then we'll return the default value. Else, we allow this to continue while setting result to the first item. Okay, and then instead of counting from index 0, we start counting from index 1. So in order to do that, we can just do something like this: if values dot length is less than 1, then we'll return the default. We'll return the default value. Else, we'll continue while setting the result to the first value in the array, and then we start reading from the range 1. Okay, now this way we are still using the default value, you know, in case you are doing addition and subtraction and all that. And then if you run the code again, we get that the result is 8, which is correct in this case because 4 times 2 is 8. Okay, so you can see that we had to do some resuffering in order for it to work really well. Now in real world scenario, we have to write a bunch of tests and test this very well to make sure that it works for every condition. When we pass 0 values, when we pass 1 value, 2 values, and so on. Okay, but you get the idea. This is how we can, by simply writing a simple code, we are able to expand and generate different functions that will accept different values, and then create addition and multiplication, and so on. You can do a lot from this. So I hope this is quite clear. Okay, in the next video we are going to explore a more complex example, which will cover how to generate structs and also implement some methods for those structs. Okay, here we are just generating functions. We could generate as many functions as we want and get them to behave in different ways, or we can also do that for structs and even methods inside the structs. Okay, so make sure you subscribe and like the video so that you get notified when we release more videos.